All right, here is Speedrun for the 2023 Part 2 number 1 fan. This is the qualifying case from the afternoon. I'm going to be using some custom lambdas and macros, which you can download at the link in the description. All right, so let's go from medium to hard as if we were actually doing this from easy to hard, right? So I'm going to start with easy, which is here in level 4, right? These license plates. I'm gonna do my X text split to go vertical here by what, a double pipe. Now, if I got this double pipe, each of these I'll just use the regular text split to go out row wise, right? By the slash here, and that, I don't need this to be really long, but it brings out kilometers per hour, but I don't know, it doesn't bother me. I use my only numbers lambda on that to pull out the digits, right? So now for the ones who are speeding, so greater than equal to 51, I'm going to add up their license plate, otherwise nothing. It's always the same number of license plates in these. So I can just add this together to get the answer to level 4. For the bingo tickets, I could do what? 2 row, let's do. So if I take this whole card here and make it 2 row with number 3, it'll ignore the blanks. So there's the bingo card as a row, and I'll give it a nice little color here. Same thing for player 2's bingo card. So that's going to go from here over to here. Give this one, whoops, not like that. I'll give this one a nice little color. And bring this, I don't need this to be this wide anymore. So what do I need to know? I need to know if player 1 won, I need to know if player 2 wins, and I need to know if we're done. All right, and I need to know which numbers got called, right? So I'm just gonna transpose all the calls here. And then, I'll add a starting position for this not copy. Starting position for this is just every number has not been called. So if your number just got called, then we'll call that a 1. Otherwise, we'll carry it down. We're going to keep the 39 locked and keep that E locked. And then this can apply to, to everything here. So player 1 wins is just the minimum of these, right? So once the minimum of that is 1, that means that player 1 won. The minimum of that tells you player 2 won. And then the maximum of these tells me if anybody won, and therefore the game is over. So, I just look up 1, meaning that we're done, on the done column, returning on sequence 90. And there's bingo. All right, now let's do the medium one. So for the snowman game, we're going to, let's transpose the guesses here. And let's say, hits, right? So how many of these are right? So count substring of the correct word with your guess, right? This is 41. So that's how many hits you got. This is how many points that's worth, right? So this, 250 for the first and 240, etc., right? So 260 minus that times 10, right? That's the number of points that each correct hit is worth times the number of hits you got, which is in G41, is the points that that's worth, right? Just like I said, you got 500, then 740. You know, you add these up and you get 1300. It's all matching. So that is the point so far. What about the snowman? So that starts out at 0, right? And then if you guess wrong, then the snowman increments. Otherwise, it's the same. All right. So now we see, have you won? Have you lost? And what is, are we done? And then what's your final score? All right. So you win if the sum of this and everything above it, right? So G41 colon G $41 is the sum of that and everything above it. So if that is the length of the word, then you won. Otherwise, no, you haven't won. If the snowman is 10, then you've lost. And then if you've won or lost, then the game's over. And then your score is the score, all the cumulative score that you've got so far is, H41, H $41. That's cumulative score. And then we got to multiply it by the winning and losing bonus. So times, if you won, then 2, otherwise 1, right? 1 is my default multiplier for no multiplier. So, and if you lost, then the multiplier is 0.5, otherwise the multiplier is 1. Right, so that's your score. So here, where you lost, your score got cut in half. So, and if you'd won, it would get doubled. So look up 1 to see if we're done, returning on the score. All right, so for the slot machine, just going to do a little sequence. It's got to be, there's 19, but we're going to start at 0 in this case, because if the thing moves 0, you go here, right? So we're doing a 0-based thing for once. So we use the built-in mod, which is 0-based, right? So just mod that based on 19. All right, and this is row 1, 2, 3, 4, 5. So now I've got my label lookup, which is like an index match, right? So label lookup on this array here, staying locked. The row label is the number of reels that you've gone. Column label is the column. So this gives you your symbols, which match the example. Now we'll just, XLOOKUP this whole thing on this thing, returning this thing. There's your points. Now, if this equals the one before it, right? Or, so if that equals the one before it, or if this equals the one after it, if either of those are true, then there's no multiplier. So we multiply by 1. Otherwise, we multiply by the value there, right? So that is there, and then that's just the product of all this. In theory, this could be wrong if they were all 1s, but I don't think that is there's no 1 here, so I don't have to worry about that special case. All right, Bear Island. Is this the last one? Yeah, it's the last one. This is the hardest one, right? So we've got Bear Island. So your house is on this cell, and the neighbors, right? So I've got a neighbors list, which just lists the neighbors. By default, it gives me, the ones around it. So that's the cells around it, your territory. So I need to know your base price. I need to know we're going to do a sand adjustment, tree adjustment, a bear adjustment, an airport adjustment, and that's it. All right, so the base is $1,000 per square feet for sand. Right. So here, just call this sand. Do this. Got a little subroutine, full color. So now I've got ones. I know those don't look like ones, but they are. I will confirm that real fast. Yep. It's ones on all the sand. So now I'm going to do an X2 call on this. It's just a little thing that turns us into a lookup table for me. Because I don't want to use I don't want to use indirect because that's volatile. All right, so now I just look up this on my sand, and all 9 cells can count toward the sand if you look in the instructions. Oh, if this is missing, by the way, then it's a 0 because it's not sand. So now I know how many sand cells there are, and I multiply that times 3. So 3 to the sum of this, right? That's the multiplication factor. Now I need to know the trees, right? So the trees, I mean, I can just X2 call off the original one here. Should have done that already. Would have copied over. All right, so if I X2 call this thing, now I can look up trees. I'm not looking up trees on the house. The house does not count. It's only the other cells that count toward the trees as per the instructions, because if you build a house, you cut down the trees. And then, you know, if it's not a tree, it's not a tree. And for this, I'm just pulling, I didn't convert them to ones, I just made them trees. So with this, I'm gonna use that. I'm gonna use a named range to call that a tree. So count if these are a tree, right? So that I multiply by something, right? 1.5, right? So 1.5 raised to the power of the number of trees is my multiplier. Now for the bears, I will make a map for the bears. We're going to need to, I want to get rid of the symbols here. I'm going to use another custom lambda here. This one is neighbors count. So it counts the number of neighboring symbols you have of a certain symbol. So neighbors count on the original list, counting this bear within 2 cells, right? So now it's a 1 if it's within 2 cells. I'm going to change the font again so we see the actual numbers. So it's counting how many of these bears are there within 2 cells. And like, oh, look, there's a bear. And so this, I can just add this to the other bears, right? So then I take this array right here and I add it to the other bear that has a range of 2, which is that bear. And then I add in the last bear, which is this bear symbol. That bear only has a range of 1. You know, I look at this on my map. There's a bear with a range of 1. There's a bear with a range of 2. You know, there's my bears. So now, and bear does count the center square, right? It does say that, including the central cell. So now, including the central cell, I'm going to look up the address on the bear. Bear, yes, no. And then the multiplication factor for bear is 0.8. So 0.8 to the sum of this, including the house, is that. And finally, airport. I have a lambda for the airport as well, just the basic chessboard distance formula, E27. So the airport is at E27. So the distance between E27 and wherever your house is, right? That's the number of airport, right? 21. So 0.98, 0.98 raised to the power of that distance is that multiplier. And if I've done it right, and I multiply all these multipliers together, and then I round to the nearest dollar at the end, got the price of the house. So this one and this one's got to do those neighbors lookups, so it takes a second. But it's filling in now. Yep, there you go. It's got the answers. So we can check. I see 8,000. That's a good sign, right? So if I've got 8,000 points, that means everything is right. Except for the bonuses. How many letters E are there in the words? Well, let's concatenate all the words, first of all, into one big string. And then let's count substring of the E. Then for this, my count substring lambda works fine with digits. Also, digits are just different types of strings, right? And I hopefully have the address here. So G124 K143, as long as I type it correctly. And I'm looking for the digit 8 as a string. 20 of those. All right, how many sand cells? I mean, I think I got this set up already, don't I? Yeah, number of sand cells is there. Which digit is most frequent on the license plate? So we'll make a special thing here for bonus 4. And instead of just pulling them out, right, I'm going to concatenate them, bring them all together. Then I'm going to concatenate all this stuff, right? Now I got a giant license plate here. Going to do string to array and highlight it all. Do my frequency table. And digit number 4 is the most common. Only one number that never got drawn in the first 16 turns. Well, let's go to Bingo Town. First 16 turns is that. And if I do a frequency table, and I sort my frequency table by the value that was called, right? So like what? This minus this tells me if they're consecutive or not. Here's a 2. Right, so look what's missing here. 66 is the only one that's missing. So 66 time 18 minutes, 19 seconds. Thanks for watching.